I promise you. Hi guys, it's painful. It's painful. I'm sorry. The network is painful sometimes. It does funky things. I'm very sorry about the network and the disconnection there. For a moment there, I can't control the network. If I could, I would, but I can't. Right? Do me this favor, guys. If you can just double tap on the screen, I'd really appreciate it. Just get the likes up there so that we can get more people attracted to the live. That would be much appreciated if you guys can do that. The more the likes, the more we can attract people into the live so that people can get exposure to the live later than never. Earlier than never. Earlier than never, ne? Yeah. The earlier they get the exposure, the better. So let's get the people in here by double tapping viciously on our screen. Don't break your screen, please. Just double tap gently and just ensure that on your part you are doing your part so that we can attract more people in here, because more people need this, right? Having an opportunity to just go through the paper 1 aspect of grade 9, especially as it relates to kids that will be writing GEC. Those who will be writing GEC, but also those who will not be writing GEC. It is not bad that you are here. It's good that you are here because you will also benefit. Okay, guys, when I got cut off, okay, I was trying to explain this development of this pattern. Okay, I was trying to explain the development of this pattern. So I'm going to just go ahead and look at this pattern again. All right. So here we counted Moss, that we have 1, 2, 3, 4, 5, 6, 7. I have a feeling I'll be disturbed here. This is grade 9, yes. This is grade 9. So share out the live to people that you think will need it. It's a grade 9 learners, yes. Okay, so as I was saying, guys, we have 1, 2, 3, 4, 5, 6, 7. Here we have 7. No. You see, people here keep on coming here and they want to ask, is it 2025? No, this is GEC 2024. Guys, I don't have the 2025 paper, and even if I did, do you think I would sit here and go through the GEC 2025 paper? Why? I would never do that. So sorry, guys. So if you are here to come and get some, I don't know, then sorry, this is not the place. I'm just here to equip learners with knowledge for grade 9, preparing for GEC or preparing for mathematics paper 1. Okay, if you are here for that, then you are in the right place. So let's look at the number of dots here. We said there are 1, 2, 3, 4, 5, 6, 7. 7 dots here. So then obviously we go there, we write down the number of dots so that we can see the sequence that we have. Then we come here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 dots. Okay, 15. All right. Then after that, yes, I also assist the grade 11s, Notando, but just not now. Right now I'm assisting the grade 9s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So we have a third term of 27. All right. I think this kite guy has been here before, and I'm going to block you kindly, Mr. Kite. I'm going to block you kindly. because you've been a nuisance in the live and you write random numbers. I don't know for what. Okay, so here we have 27 number. So this is pattern 1. Pattern 1 has 7 dots. Pattern 2 has 15. Then pattern 3 has 27. Now we are being asked which pattern represents pattern 4. Okay, which pattern represents pattern 4? You're welcome, Zanenhlanhla Khuzwayo. Thank you so much for your comment. So which pattern represents pattern 4? So what we are going to do is we are going to ask ourselves, what is the number that represents pattern 4? So currently, we need to check first, what is the first difference of the sequence? Because I can see that the numbers are pretty close, okay? So there's a difference here. This is 15, this is 7, yabo? So 15 minus 7, that gives us 8. Yeah. Then 27 minus 15, that gives us 12. Okay. So it seems like here we have a first difference, but it is of 8 and 12. Okay. This first difference, guys, okay, seems to give me vibes of a linear pattern. Okay. Because my first difference is not constant. It is giving me vibes of another linear pattern. So what I'm anticipating is that I am going to actually have a second difference for this particular pattern. My second difference, guys, is simply going to be 12 minus the 8, which gives me 4. Now please note something here, guys, that 7 plus 8 is 15. 15 plus 12 is 27. Yes, guys, difference does mean minus. So when we say first difference, we are taking this term minusing the previous term. So difference means that 15 minus 7 is 8. 27 minus 15 is 12. So this is what we call the first difference row. And this row forms a linear pattern. All right. So when we want to calculate now the second difference from the first difference row, we say 12 minus 8 gives us 4. Okay. So if you look at 7 plus 8, that gives you 15. 15 plus 12, that gives you 27. 8 plus 4, that gives you 12. Now what I'm noticing is that my second difference, because this type of pattern is the type of pattern that has a second difference, which I am anticipating will be a second difference that is constant. It's not the first difference, but it's the second difference. That means my number here for the second difference will also be 4, because it is the second difference that is constant. So what is 8 plus 4? I get 12. What is 12 plus 4? That means the number here will be 16. But remember, this will help me to be able to get my pattern number 4 number. What's 27 plus 16? I get the amazing number 43. So what I know is that pattern number 4 is going to have 43 dots. 43 black dots will be occupying pattern number 4. So all I need to now go and do is I need to go back to my diagram and go and locate that pattern that has 43 dots. Okay, I'm going to go to that pattern that has 43 dots. It's as simple as that. So we are vibing with vocabulary, and we are saying that the vibe of the number of the pattern that has 43 dots is going to be C. Vibing indeed, vibing indeed, vibing with vocabulary. So yes, it is 43. So then we can say our option that we choose is C. So once again, this is another type of pattern that we are having here. Very different, guys, from the patterns. Okay, this previous pattern, remember the one that we saw before, this one, It was not having a constant difference, neither was it having a constant ratio. So it was very different from what we are used to. Okay? This one as well has a second constant difference, right? It is not a pattern that has a first difference like what we are used to. Okay? So we need to then become a bit more familiar with more than just the patterns that we learned when we were in class. We need to get exposed to other questions that relate to patterns. Let's move on to the next question, guys. J makes a pattern with squares. Who? J makes a what? A pattern. He makes a pattern with what? With squares. So there is the first square, there is the second square, and here is the third square. Now you can see what this boy or this girl wrote in his paper. Let's confirm, guys. The first square, we are told what will the area of the ninth square be? What will the area of the ninth square be? Now I want us to come first and say this is the first square. It has 2 centimeters. Each side has 2 centimeters. The area basically of this particular square, the area of this particular square, the first one, will be what? Remember, the area of square is side times side. So that means we have 2 centimeters times 2 centimeters, which means the area of the first square is going to be 4 centimeter square. All right. I'm sure you guys can see the pattern. Then remember, that is my first one with sides being 2 centimeters. Okay. I've used the area to find the area of the first square. It is 4 centimeters squared. What about my second square? Each side of the square for my second square is 4 centimeters. So what is the area of that particular square? Area is equal to side times side, so I know it's 4 centimeters times 4 centimeters. What does that give me? 16 centimeters squared. That is my second square. Okay. What about my third square, guys? I want you to get the point here. My third square has, each side is equal to 6 centimeters. Each individual side is 6. So what is the area of that particular square? 6 centimeters times 6 centimeters. What does that give us? 36 centimeter squared. So I hope we are together here. From what? From 2 to 4 to 6. 2, 4 to 6. Are we together, guys? 2 centimeters, the first square, each side. 4 centimeters for the second square. 6 centimeters for the third square. I hope you know where I'm going. So that means there's a pattern for the length of sides that we see. 2, 4, 6. So that means for square number 9, what will be the length of the side of square number 9? Just the length of the side of square number 9. Because what do we want here? The area of the ninth square. Okay, so this is square number 1, square number 2, square number 3. These are the sides that we have. My question is, what will be the length of the side of one square for square number 9? That is what I'm asking here. Okay. Now, position 2 times 1. Position 2 times 2. Position 2 times 3. So square number 9, position, that will mean 2 times 9. So what am I expecting? I'm expecting that the length of the side of the square for square number 9 will be what? 18 centimeters. I'm expecting to be 18 centimeters. One side of that particular square for square number 9 will be 18 centimeters. I hope you understand, guys. Remember, for square number 1, 2 centimeters is the length of the side. We calculated the area, we got 4 centimeters squared, and so it goes. But what about square number 9? Okay, to get the length of each side, guys, do you see what I did? Do you see what I did? I hope you see what I did. So the area for the square, for square number 9, is going to be 18 centimeters times 18 centimeters. Hopefully you are with me, guys. 18 centimeters times 18 centimeters. Which gives me what? What's 18 times 18? All right. From your calculator, you get what? Don't you get 256 as your answer? 18 times 18, 324. Aye, guys. Aye. Is it 324? Are you sure? I'm kidding, man. I just wanted to see if people wouldn't change their answers. You know, sometimes you guys rely more on the teacher than you do rely on yourself. I wanted someone to actually change their answer and be like, no, sir, it's actually this. Yes, so it is 324 centimeters squared. Okay. I hope that makes sense. Okay. I hope that makes sense. Because here we were able to establish a pattern. Term 1 is 2. Term 2 is 4. The pattern here is established according to the sides of the square. So this is a pattern established according to the sides of the square. Term 2, term 3, 2, 4, 6. So you could go all the way to term what? Term 9 for square number 9. What is the length of the side of a square for square number 9? It is obviously going to be 18 if we are going to continue moving in twos. 2, 4, 6, 8, 10, up until square number 9. So if for square number 1 it's 2 centimeters, for square number 2 it's 4 centimeters, for square number 3 it's 6 centimeters, for square number 4 it would be 8, square number 5 it would be 10, square number 6 it would be 12, square number 7 it would be 14, square number 8 it would be 16, and then square number 9 it would be 18. Once we know and have established the side of the square, then we can simply now use the what? The formula for area of a square. We know area of a square is equal to side times side. So then what do? We take each individual side, we multiply side times side for a square, and we get 324 centimeters squared. So that means the area of the 9th square would be 324 centimeter squared. Maybe let's say they had asked a different question from this one. Say they had asked, what is the rule of the sides of the square? What is the rule of the sides of the square? Then what you would do is you would write 2, 4, 6. Okay. Then you'd want to establish what type of sequence is this? 2, 4, 6. So this is a what? This is a linear sequence. What do we know about the linear sequence, guys? Linear sequence is simply given by a general rule that says Tn is equal to Dn plus or minus C. What is D? D is the constant difference. What is C? C is basically that number that you add or subtract to the nth D to get the value. Okay, so what we would simply do here is we'd first calculate D by saying T2 minus T1, okay, term 2 minus term 1, and then confirm it with term 3 minus term 2. Because remember, for it to be a constant difference, we must see that the first difference is the same throughout the sequence. So if you say term 2 minus term 1, that means 4 minus 2. What's 4 minus 2, guys? That means the constant difference is equal to 2. Then what you do is you go and say Tn is equal to 2n, and remember, you still need now to find the value of C. Okay? Now, there is a formula that you can use to calculate the value of C, and that is, to get the value of C, you simply take term 1 and you subtract the constant difference. You take term 1 and you subtract the constant difference. That is one way of getting C. Thank you so much, Mr. Physics there. I see your lives as well, Mr. Physics X Tutor there. Guys, there's a person called Physics X Tutor there in my comment section. Guy does the most. I usually vibe into his lives sometimes. I think he is both maths and physics. You know, he's one up on me. He does the most there in that channel. Gets that live up and rolling, guys. If you guys really and truly, you know, want to get it from some of the best in this platform, Mr. Physics X Tutor is the man. He's the man, he's the man, or she is the woman. All right, let me just leave it at that. Okay, C is equal to T1 minus D, guys. You can use this formula to calculate the value of C. So that means C is equal to, what is term 1? Term 1 is 2 minus D. What is D? D is also 2. So 2 minus 2 is equal to 0. Okay, there, Physics X Tutor has confirmed he is the man. All right, so here we are, guys. That basically means that C is equal to 0. So all we do now is we confirm and say 2n plus 0, but we know most Tn is equal to 2n would be the rule for this particular sequence. So that's how you get the rule of a linear sequence. You first find D. What is D? It is the constant difference. How do you calculate it? You take term 2, you subtract term 1. Don't say term 1 subtract term 2, please, guys. You say term 2 minus term 1. Are we together? Okay. Then you say term 2 minus term 1, which is 4 minus 2. 4 minus 2 is equal to 2, so the constant difference is 2. Then you simply say Tn is equal to 2. 2 what? 2n plus C. You calculate the value of C. How? There is the formula. C is equal to the first term minus the constant difference. So if you have the first term, you can subtract the constant difference, then you'll get your C value. Then you come back, you substitute into your rule. There is the rule. Tn is equal to 2n. What does n stand for? N stands for position. So the position, all right, of the term in your sequence. For instance, if I want to find the value of term 2 for this sequence, term what? Term 2. That means I want to find the term that occupies the what? The second position. So I'm going to say T2 is equal to, then in the place of n, I'm going to substitute the position n in the place of 2. So that means 2 times 2. So term 2 is equal to what? 4. Does that make sense that term 2 is equal to 4? Indeed, because your term 2 is 4. All right? Let's say they said, find the 100th term in your sequence. That means you find the position of the term that occupies the 100th position. So if you have your rule, you can simply go and substitute in the place of n 100, and then you will find your 100th term. It is equal to 200. So that's what n stands for. N stands for position. Do you understand now? N stands for position. What does n stand for? Position. Hopefully you know your position. Okay. The person who asked about n and all of that, are you clear? Annalisa Faith, do you have faith now? Annalisa Faith, do you have faith now? Oh no, Annalisa Faith. Annalisa, where are you? Comment in the comment section, please. Yes, this will be on YouTube. I will upload it as soon as I'm done. Will this be on your YouTube? Yes. Where is Annalisa Faith? Annalisa Faith went to AWOL. Okay, Annalisa Faith asked a question but went AWOL. Okay, let's move on to the next question, guys. So the answer there for A was 324 centimeters squared, and I hope we are good. Let's move on to this. Now we are entering into the zone of algebraic expressions. We need to know algebraic expressions, my beautiful people. Which of the following are like terms? What are like terms, guys? Like terms are terms that have the same variable with the same exponent. Say that again with me. Like terms are terms that have the same variable with the same exponent. Are we together? Once again, what are like terms? Like terms are terms that have the same variable and the same exponent. It's like terms, guys, are terms that have the same uniform. It's like kids that go to the same school. When a school is operating well and the kids are wearing the same uniform, you can see the uniformity and you say those kids have like uniform. That is what we call like terms, right? So if you look at this, 2pqr squared, there's a p, there's a q, there's a r. The p, there is no exponent. The p here has exponent 2. Immediately, this is not a like term with this one, because the p and this p, this one has 2, this one does not have 2. Out. Look at b. -7, there's a p, there's a p, there's a q, there's a r, This q has a 2, this r has a 2. There's no r, there's no q. No like term. Look at this one. There's a p, there's a p, there's a q and a q, but this has a 2. This one has a, oh no. This r, there's an r, there's a r. This one has a 2. No. These are not like terms. Let's look at this term. There's a p, there's a p, there's a q, there's a q, there's a 2 and a 2. Yes. There's a r and r, there's no exponent, there's 1 which we cannot see. So D indeed is what we call what? Like terms. Like terms have the same variable with the same exponent. These are terms that have the same, that are wearing the same jersey. They are from the same school, these kids. You can see them. He is wearing a tie, he's wearing a tie. He's wearing a school shirt, it has no writing on it. He's wearing a school shirt with no writing in it. His school shoes are black, his school shoes are black, they are shined. You see, so these are like terms. Of course, when you look at the kid, the one kid is coming to school with a very negative attitude, the one kid is coming to the school with a very positive attitude. That does not make it unlike. The coefficient does not make it unlike because it is different. It is only the variables that basically dictate like and unlike. P, there's a Q, there's a Q, square, there's a R, there's a R, Doesn't matter the order. If they had put the order differently of letters, as long as there's a P and there's a P, there's a R, there's a R, there's a Q with a 2 and a Q and with a 2. The order doesn't matter of the letters. We would have still said these are what? They are like terms. Like terms have the same what? Letter. Like terms have the same exponent for their letters. Guys, I hope you get me and you get me loud and clear. Let's go to 24. So 23 is D. No calculating on the side needed. You can just select the answers. Guys, there are questions in the GEC paper that you are going to see. Here, I can just select the answer. Here, I need to do some working out. So where you have to do the working out, you do the working out. Huh? Okay, let's look at this question. Negative 2x cubed plus 3x squared minus x plus 8. What is the exponent of the term with the smallest coefficient? They are asking, what is the exponent of the term with the smallest coefficient? Now we need to unpack terms here. Do we all understand what an exponent is? Okay, firstly, for this here, first and foremost, what is a term? A term, guys, is a coefficient with a variable, or sometimes it is a number alone, separated by a plus or a minus sign. So if you look at this algebraic expression, we have 1 plus sign, 2 minus sign, 3 plus sign, 4. 4 terms in this expression. That's the first thing we need to note. How many terms in the expression? We have 4 of them, because terms are separated by a plus and a minus sign. Then they are asking what is the exponent of the term. So we know what terms are. This is a term, that is a term, that is a term, that is a term. What is the exponent? What is an exponent, guys? An exponent, look at this, negative 2x to the power 3. This to the power 3 is an exponent. This to the power 2 is an exponent. This x here has an unseen exponent that people, because they don't see it, they believe does not exist. It's like people nowadays believe God does not exist because they don't see him. Guys, this 1 is there, even though you don't see it. That's an exponent. 8 is a constant term. So they're asking, what is the exponent of the term? And they're asking, with the smallest coefficient. What do they mean by coefficient? Guys, a coefficient is that thing that stands next to a variable. It is that thing that stands next to a variable. So, for instance, this variable and its exponent, what is standing next to it? It is negative 2. That is the coefficient. The coefficient of x cubed is negative 2. What is the coefficient of x squared? The coefficient of x squared is that thing that stands next to x squared. It is positive 3 here. What is the coefficient of x? The thing that is standing next to x, which we cannot see, is negative 1. Guys, there's a minus 1 there. It's there. It's there. What is the coefficient here? Well, guys, this is a constant term, so there is no coefficient. So they are asking, what is the exponent of the term with the smallest coefficient? The exponent of the term with the what? With the smallest coefficient. What is the exponent, I repeat, of the term with the smallest coefficient? So let's check smallest coefficients here. Negative 2 is a coefficient. We are comparing it to 3. We are comparing it to negative 1. Who is the smallest between negative 2, 3, and negative 1? Let's start there. Who is the smallest? Negative 2, 3, and negative 1. Who is the smallest number here? Negative 2 is the smallest coefficient. Okay? Negative 2 is the smallest coefficient. That's what we need first to identify the smallest coefficient. But what are they asking for? Are they asking for the coefficient? No. They are asking what is the exponent of that smallest coefficient. So we know the term we are looking at is this one. What is the exponent of that term? There it is. The exponent of the term is 3. So therefore the answer is D for 3. Okay? It's important to read. You see, that's why I'm saying some of you are not going to be able to do the maths because the English is not Englishing. There is no comprehension of the English. Therefore, with no comprehension of the English, then the maths is not mathsing. So I repeat again. What is the exponent? What are they asking for? They want the exponent of the what? Of the term. With the what? With the smallest coefficient. So firstly, you need to go and identify the smallest coefficient in your expression. Which one is it? It's negative 2. Because 3 is bigger than negative 2 as a coefficient. Negative 1 is bigger than negative 2. 8 is a constant term, guys. Okay? So between these, negative 2, 3, and negative 1, which coefficient is the smallest? Obviously, it's this one, negative 2. Which one is the exponent? What is the exponent of that term? There it is, guys. The exponent of that term is 3. So the answer is D. The answer is D. Okay? The answer is who? It is D. Just for your information, guys, some people don't know that a constant term, in actual fact, if the variables here are all x, then this constant term simply has a variable x which is raised to the power 0. Some of you may be asking yourself, why in the world did they say 0 here, for instance? It's because even though they didn't put the x to the power 0, that's something they know you should know. And so had they said, for instance, what is the exponent of the term with the highest coefficient? Look at this. What if they had said to you, what is the exponent of the term with the highest coefficient? Then my question is, what would have been your answer? What is the exponent of the term with the highest coefficient? Now I know for a fact most of you would have said, this here is your answer. Most of you would have said, the highest, most of you would have said, sir, the first and foremost, the highest coefficient here, guys, is 3. And therefore, if the highest coefficient here is 3, then it means the exponent is 2. And in that moment, you would have lied to all of us. Okay? What is the exponent of the term with the highest? If you had said the highest coefficient, guys, this is the highest coefficient. It is 8. Its variable is x to the power 0. The exponent is 0. There it is. That would have been your answer. Okay? I am just exposing you to things like this so that you guys are aware, alert, and awake. Okay? Okay? Alert and awake. Because as I said, this initially was just 8. But I can tell you this one thing. People mostly don't know, since these terms are all x terms, x cubed, x squared, x, this constant can be written as 8x to the power 0. Because what is a variable raised to the power 0 equal to? It's equal to 1. So saying x to the power 0 does not change this 8. So if the question had said, what is the exponent of the term with the highest coefficient? You would have first had to identify the highest coefficient. So between -2, 3, and -1, most of you would have said, this is the highest coefficient, it's 3. But not understanding or seeing that even with the 8, 8 becomes a coefficient if we consider that 8 can be written as what? 8x to the power 0. And therefore the highest exponent, the exponent with the highest coefficient is actually this term, and therefore the exponent is 0. Okay, so I hope you understand what I mean for that. Fortunately, guys, like I said, that was just to expose you guys. What is important here is to know expression, okay? To know expressions and to know your coefficients, what a coefficient is, what a variable is, what what a constant term is, and so it goes. Someone was asking, what is the answer for 22? The answer for 22, guys, is 324 centimeters squared. Why is it 324 centimeters squared? Because I explained. You guys can catch it on the YouTube channel when you watch the video which I will have uploaded. Okay? Guys, I'm going to end this live at 3:30 exactly. So if you are here and you're wondering, when is this guy going to end this live? I'm ending it at 3:30 exactly because I can't stay any longer than 3:30. I might just take it up to 4:45, but up until 3:30 is where I'm intending to have it. Okay, let's look at this. How many terms are in the expression? Okay, how many what? Terms are in the expression. Vibing with Vutlari is saying there are 3. Okay, meaning Vutlari is saying D is the answer. Tando is saying it's C. How many terms are in the expression? Let's look at this. This is -5xy times x to the power 5 minus y squared over 3 plus 5 brackets x. So when we look at these and we count how many terms we have, do we still remember what I said? What is the separator of terms? There are operations that are called separators of terms. The ones that separate. The ones that cause a divorce to happen. They separate. You know, you go on holiday, you cry. You're like, no, we cannot be separated. Or whatever it is. The divorce. The ones that cause divorce to happen. That separate. You know, they don't like unity. Plus and minus, guys, are the ones that separate terms. Okay, then there are the combiners of terms, the ones that cause unity, the ones that combine terms. Who are the ones that combine terms? Who are the guys that are responsible for combining terms? Because it's important to understand that. Once we understand the separators and the combiners, then when we count the terms, we will count correctly. So who combines terms and separates terms? If plus and minus separate terms, then who is the one that combines the terms? Okay, it is multiply and divide. They are the ones that combine terms. Yes, Sihle, very good. Okay, and also our favorite ones, Mr. Bracket. Brackets, divide, and multiply are the ones that cause unity. So if you want to get married forever, guys, this is my suggestion to you. One day you will find that person that you want to spend the rest of your life with. When you guys are there at the altar, make sure multiplication is there. Make sure division is there. And make sure brackets are there. What is multiplication? First and foremost, you must make sure for unity to occur, make sure that you multiply and replenish the earth. You have the children so that there can be something else that combines or unites you guys together. Division. Make sure, guys, that you divide yourself from, you keep yourself, you basically make sure that anything that comes your way, you keep it away. Okay, I'm talking to people who will be married, guys. This is what I want to be united forever. Then make sure to put brackets around. Put brackets around yourself. Do not look left and right. When you see someone else, though attractive they may be, pretend as if you have brackets around you so that you do not get distracted from your partner. These are the tools that ensure we are becoming one. We are combined, not separated. Relationship advice 101 using mathematics. So please, guys, plus and minus, they separate. Thank you, Lefty, for the rose. Plus and minus, they separate. Multiply and divide and brackets combine terms, they become one. Come here now. Come here now. And I ask you again. We are still learning maths, guys, just in a fun way. How many terms are in this expression? 5x, negative 5xy times x to the power 5. So when you are counting the terms, how many terms are you seeing here? This is 1. All of this is one term. Immediately after that, we see a minus sign. We have a second term now. Because the combiners combined, we are one. We are one. You know what I mean? Minus separates, we can count 2. Plus separates, we can count 3. Please, guys, know how to count terms. As well as y squared over 3. This is one term because a fraction is one term. Okay? So the people that said D, 100% correct. You guys are simply the best. Never na 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 na. You know what I mean? You guys are simply the best. So yes, please, let's never make the mistake of not knowing how many terms we have. Let's go to number 26. Yes, Hekelfin, it is. Minus 3y into 2y squared minus 4y, the bracket closed, minus 1. Guys, before you simplify this thing, I need you guys to be in the habit of when you have an expression, please, I beg you, first establish how many terms you have. Okay? There's a reason why when you begin algebraic expressions, they start with algebraic language first. They do that thing of saying, 6 less than a number. There's a reason why they start there. They start with those simple simplistic things. 6 less than a number. Then after that, they tell you what a variable is. They tell you what a term is. They tell you what a constant is. They tell you what a exponent is. And then they tell you how to count the number of terms. What separates terms? What combines terms? They start with those basics. Why? Because as you get here, then it's like, you know what you know. You look at this and you're like, how many terms do I have in my entire expression? In my entire expression, how many terms do I have? Guys, we can count most. We know what the separators are. We know what the combiners are now. We know plus and minus separate terms. We know that brackets and multiply and divide, they combine terms. So knobs, ZM, thank you so much. There are 2 terms in this expression. Now, knowing that this one term, 1 is alone, what do you see in this one term? You see a relationship in this one term. You have negative 3y, which is a monomial outside the bracket. Then inside this bracket, guys, you have 2 terms. So that means you can take this negative 3y and distribute it. You can do what to this negative 3y? You can distribute negative 3y into 2y, distribute negative 3y into negative 4y. But when you do so, now I love this one, you apply or use S and L. I'm sure you've seen this, guys, somewhere on TV. You are watching the movie there and you are enjoying, you are watching, but it has these letters. Guys, these are not letters that you should be enjoying watching movies of. Don't watch these movies. If you've been in my life, you know I've spoken about S and L too many times. What does S stand for? S means sign, N number, L letter of the alphabet. So now we are turning the tide from the movies to the maths. S sign, N number, L letter. So when we apply this distributive law, when we distribute negative 3y to 2y squared, in your mind, what must you do? You must make sure you are multiplying the sign, multiplying the number, multiplying the letter. Okay, so let's look at this, guys. Let us simplify this thing. Let me get a fresh page. It needs a fresh page, this thing. Let me rewrite that question. We have negative 3y into 2y squared minus 4y minus 1. I've already established how many terms there are. There are 2 terms. 1, and then this one is all alone, Shem. Very much alone. So let us apply the what? The DL using S and L. What is DL? The distributive law. Take negative 3y and distribute it to 2y squared. Why are we doing that? Because the brackets in maths mean multiply. The brackets in maths mean multiply. The brackets in maths mean multiply. So negative 3y is going to be multiplied to the first term inside this bracket. And when we do so, we are going to check sign. Negative times a positive, it's equal to what? Negative. Sign is sorted. We go to the number next. 3 times 2. What's 3 times 2? It is 6. Number is done. We go to the letter. Y times y squared. Y times y squared. Remember the laws of exponents? A to the power m times a to the power n is equal to a to the power m plus n. Bases are the same when we are multiplying. What do we do to the exponents? We add them. So that means we are going to get y to the power. Let's not forget, there's a magical number 1 there, like the Holy Spirit, always ever present, unseen many a times, but doing an amazing work in the background. 1 plus 2 gives you 3. So we have negative 6y cubed. Now, to answer the question for the person who was saying, why is Sen now saying 2 terms? Guys, listen to me. This is one term. I agree fully. Because this is negative 3y, there's a bracket. So the bracket makes it 1. The relationship of bracket with 3y is multiply, so this becomes one term. When I was saying there are two terms, I'm talking about inside the bracket. Inside the bracket, I am taking negative 3y and distributing it inside where there are how many terms inside the bracket? Remember, inside the bracket, if I'm looking at inside the bracket, we're looking at what? 1, there's a minus sign, 2 terms inside this bracket. Okay, I hope you understand me now. So when I distribute my first term to the first, I get negative 6y cubed. S, negative sign. The sign is negative. N, the numbers multiplied give me 6. L, the letters y to the power 1 times y squared, applying law number 1 of exponents gives me y to the power 3. Then I'm going to take the same negative 3y, thank you TG for the rows, you distribute it to the second term inside the bracket. There's a difference of when I say two terms inside the bracket. I hope that makes sense to you guys. Okay? Take the negative 3y, distribute it to the negative 4y. We apply who? S, sign. What's a negative times a negative? Hopefully, guys, we know our signs. Negative times a negative gives you a positive. So it is positive. 3 times 4 is 12. Y times y. You see, I move from the sign to the number. Now I'm busy with the letter. Y times y gives me y. Bases are the same. What do I do to the exponents? There are those invisible ones. Y squared. Bracket has been removed. When we distribute, then the brackets get removed. Okay? And then we place the minus 1, which is the term that was waiting there. Now this negative 1, if we compare these 1, 2, 3 terms, we do not have any like terms. When we have unlike terms, guys, the answer is complete. Why do we say these are unlike terms? Because if you look at 6y cubed, y cubed has a different exponent from y squared. So even though there's a y and a y there, the exponents are different. So therefore, these two are unlike terms. The exponents are not the same. We cannot add unlike terms. Minus 1 is on its own. It does not even have a variable. So therefore, we say this is the answer. So if we go now to your option, it's easy to choose. You choose the right option according to your beautiful answer. So which answer satisfies that answer that we have there? Is it A? You look there, you're like, B? I corner B, sorry. C? No. D? Out. So it is A, guys. A is the answer. Negative 6y cubed plus 12y squared, positive 12y squared, minus 1. It is A. Once you've gotten the right answer, guys, please don't select the wrong answer. That would be very shameful. You wrote the things correctly, then you go and select the wrong thing. Then you are sabotaging yourself. Okay? You are sabotaging yourself. Okay, let's look at the next question here. Ooh, now this one is quite nice. 15y cubed minus 3y into negative y plus 2 plus 6y squared. We're looking at the numerator here, guys, and it's very important. We ask the famous question that I love asking before I even do anything. You ask, how many terms in the numerator? Okay, now, one thing to note is that this whole entire thing is a fraction, so that means one term. Okay, fraction always means one term. Had they asked you had they asked the question, guys, okay, had they asked how many terms are in this actual expression, you would have said there is one term. Fraction means one term. But now, when you look at the numerator alone, okay, how many terms are in the numerator alone? There are 1, there's a minus sign. There's 2, there's a plus sign. And then there's 6y squared. So we have 3 terms in the numerator. Look at the denominator. We have 3y. Now we are required to do what? To simplify. All right? To do what? To simplify. So what I'm going to do for myself, because I am the person that I am going to basically do the following. I am going to simplify the numerator first, okay, before I even look at what's happening in the denominator. So let's go and simplify the numerator first. Okay, let's go simplify the numerator first. So we have 15y cubed minus 3y into negative y plus 2 plus 6y squared. Okay, so far we are like, okay, looks good, looks nice. Everything seems to be over 3y. So let us simplify the numerator. In the numerator, we have 15y cubed. Let's take this negative 3y and distribute it into the bracket. Okay, let's do that. Distributive law, we use check SNL. Make sure sign, number, letter as you multiply. And negative times a negative gives us a positive. 3 times 1 gives us 3. Y times y gives us y squared. Okay, hope that makes sense. Then lastly, negative 3y times positive 2. And negative times a positive gives us a negative. That's a sign. Complete. Number 3 times 2 is 6. Then the letter y. With nothing times y, just stick the y, combine it with the 6. That's negative. Then of course here we have the plus 6y squared. Over what, guys? That's all over 3y. Okay. Now, before then we even complete answering this question, after having simplified, it's very clear now that we have how many terms? 1, 2, 3, 4 terms, because we have distributed and simplified the numerator. Are there any like terms that we can see there in the numerator? Any like terms that we can see? Well, there are. We have 15y cubed. All right. Negative plus 3y squared plus 6y squared. We can add these terms together. This is plus 3 plus 6. Why? Because the y squared and the y squared, they are terms with the same uniform. That means we can add 3. This is a positive 3 plus 6. What is 3 plus 6, guys? It is, as Super Not Angel is saying in the comment section, it is 9y squared minus the 6y. That's all over what? 3y. So far we are going so beautifully and swiftly. We've managed to make the numerator a bit less complicated by simplifying it. All right, and so far what we have is 15y cubed plus 9y squared minus 6y all over 3y. Now, Sohan Singh, you are 100% correct. What we are then going to do now, because of our grade 9 knowledge, in the numerator we can see that we have a what, guys? We have a 1, 2, 3 terms, and these terms we can actually factorize them. All right, the splitting method was something we applied in grade 8 that can also be used, but because we are in grade 9 and we've been exposed to factorization, we know that whenever we can see that in our terms, the first thing we always check, is there a highest common factor? If a highest common factor can be identified, we identify it according to S and L. Hey, S and L is coming out everywhere. We identify highest common factor according to S and L. Look at the three terms. And the reason why we are saying we are going to do that is because this 3y that is here, it means we can simplify that 3y if we can take out something in the highest common factor that can simplify the 3y in the denominator. Okay? So William in the comment section is saying when he looks at the three terms in the numerator, he can see that there's a highest common factor of 3y. Let's confirm if that is true. Let's look at the numerator. We have 15y cubed plus 9y squared minus 6y. Okay, are we together? And there, we need to check, do we have first the highest common factor sign? Guys, what is the highest common factor sign? The first term in your expression always contains the highest common factor sign. So since it's 15y cubed, it means the highest common factor sign between 15y cubed and 9y squared and negative 6y squared is positive. We then move on to the number. Between 15, 9, and 6. Remember, the sign is already taken care of. We don't have to worry about that anymore. We are looking at 15, 9, and 6. What is the highest common factor? Or in other words, what is the highest number that goes into 15, goes into 9, and goes into 6 without leaving a remainder? Okay, that highest common factor number is 3. Thank you so much, guys. It is 3. Okay, 3 is the highest number that is divisible, all right, by all these numbers. Or it is the number that goes into 5, into 9, and into 6 without leaving a remainder. If you guys have forgotten how to find the highest common factor, it becomes of importance that you know how to find the highest common factor. Then we conclude, what is the highest common factor letter or variable? Now, to identify that, you always choose the common base variable that has the lowest exponent. That is how you identify the highest common factor letter. It is the common base. So the base variable that is common is y, y, and y. That letter is common for all three terms. But which one has the lowest exponent? It is not 3, it is not 2, it is y to the power 1. So that means y is the highest common factor letter. So guys, when you write down the highest common factor, you want to identify the highest common factor from a list of terms. Make sure to first identify the highest common factor sign. How? You look at the first term. That will give you a hint as to the highest common factor sign. Then the highest common factor number. You look at the numbers you have for all three terms, 15, 9, and 6. Which number is divisible by all three? The highest number, it is 3. Then you look at the highest common factor letter. Is y the letter common? Guys, it must first be common everywhere in order to be identified as a common factor letter. So the common base variable with the lowest exponent is the highest common factor what? Letter. So in this case, it is y. Not y squared, not y to the power 3. So what do we do after that? We take that out, the highest common factor, sign number letter, which is positive 3y. Take that out. Then you open a bracket. What is left inside? What remains for the first term? You took out 3y. Now, to get 15 back, what do you multiply 3 by to get 15? Or you can say, what is 15 divided by 3? Okay, that gives you positive 5. Sign is positive because you had a positive taken out. A positive times a positive gives you a positive. Number, 3 times 5 gives you 15. Letter, y times what gives you y to the power 3? You took out 1y. You need 3 of these y's. How many y's do you need to add to 1y to get 3? You need 2 of these y's. So therefore, it's y squared. Are we together? Y squared. So now when you distribute the 3y back, you get 15y cubed back. So I know this is correct. Let's move on to the next term. 9y squared. I took out 3y, guys. I need 9y squared back. This is positive. I need a positive. Positive times what gives me a positive? It is a positive. Sign is taken care of. You see this SNL thing? Stop watching those rubbish movies with SNL guys and start tuning into the maths. Sign, number, letter. Sign, number, letter. The next time you are confronted by those movies, switch off the TV and watch. Stop watching nonsense. Come and do maths, SNL. Get good in your algebraic expression. It will lay a good foundation for your grade 10, 11, and 12. You will not struggle with maths in grade 10, 11, and 12 if your expressions are good. 3y times what gives you 3? 3 times what gives you 9? It is 3. Or you can say 9 divided by 3. It is 3. Look at it in 2 ways. 3 times what gives you 9? It is 3. Or you can say 9 divided by 3. What is 9 divided by 3? It is 3. 2 ways of looking at it. The y is out, 1 y is out. You need 2 of them. How many y's do you need to add? You just need to add 1 y. Are we together? 1 y. Okay, so it's 3y. Then the last one. 3y times what gives you negative 6y? 3 times what? Positive times what gives you a negative? It is a negative. Then 3 times what gives you 6? It is 2. What about the y? What about the y? The y is already out. Do we need another one? Yeah, we don't need, guys. It's finished. It is clear. Remember, this was all over 3y. Yeah. Now I see the light. I can see the sunshine. Oh my goodness. I see the heaven, yeah, heaven is over me. There, I can see the heavens now, guys. 3y is a common factor taken out. 3y is my denominator. Now, I can play what I call the cancel game. But the cancel game does not happen across an addition or subtraction sign. What do I mean by that? This is what I mean by the cancellation game does not apply across an addition or a subtraction sign. So for instance, look at this. This is 3y plus 5 over 3y. Some people do this, and they cancel. But you see, guys, there's a rule to cancellation. Cancellation does not happen across an addition or a subtraction sign. We don't But look here. The 3y is not across an addition or a subtraction sign. The 3y is next to a beautiful bracket. And it's all over 3y. So I can cancel nicely y because I am not cancelling across an addition or a subtraction sign. Usually you'll have people who want to cancel this 3y and that one. No, you can't cancel this 3y and that one because it is across an addition and a subtraction sign. We don't cancel across an addition and a subtraction sign. But if the 3y is outside, then, oh, beautifully so. Because 3y divided by 3y, that leaves us with 1 in the numerator and the denominator. Okay? That cancellation does not mean we have nothing. We have something. All right? We have 1 that is left behind. Because 3y divided by 3y is 1. Okay? So it's like 1 over 1. Then what gets left behind? The 5y squared. The 1 gets distributed, 5y squared. The 1 gets distributed to 3 plus 3y. The positive 1 gets distributed to negative 2. It's negative 2 because 1 multiplied by another number gives you exactly what you have. That is your answer. Guys, some of you might be here and be like, sir, you could have finished this problem long time ago. You just wasted time. No, I didn't. Guys, why did I do this? It's because I'm trying to remind you of factorization. When